Hello, everyone. A very good afternoon to all of you. I am Ella, welcoming you all on behalf of Solar Quarter and First View Group to the Next Gen Solar, unraveling the latest developments in PV technology. I take the pleasure of thanking our panel members for extending their immense support to organize this event, and a very special mention to our sponsor, Growatt, for being our crusader here. I would now request my team to play the commercial video for Growatt.
We thrive on fire and shine with electricity. Energy carries our progress and prosperity. But with natural resources dwindling and ecosystem damaged, what lies ahead for us all? To blaze a trail towards a sustainable future, Growatt delves into unlocking the full potential of renewable energy for you and me, making energy smarter and the future greener. We bring innovations to propel clean energy revolution and pave the way for an eco-friendly future. We make the most of every beam of sunlight by developing all scenario solutions to decarbonize our ways of living. We illuminate homes and enable everyone to share the joy and benefit from sustainable energy. We create possibilities for sustainable development, facilitate smart energy management for optimal energy use and cost management. By engineering reliable, powerful, and intelligent energy solutions, we deliver secure power supplies for homes, businesses, and communities. We are dedicated to building the world's largest, intelligent, sustainable energy ecosystem for all humans. We hold ourselves to comprehensive and strict engineering and quality control standards by implementing the 5-step quality engineering system, from product design to manufacturing. For every product we deliver, it's a business success story unfolding. In this journey of unceasing exploration, we craft meaningful products and solutions for everyone in the global community. Together with our global partners, we shoulder the responsibility to create a green and sustainable future for generations to come. By unlocking the potential of our global workforce to innovate and contribute, we strengthen our capability and make bold moves to protect our planet. It's our vision, our mission to shape a greener world and a better future.
Thank you, team. May I now introduce Mr. Shantanu Srisat, Technical Head India Growatt, to share the presentation for his company.
Yes, thank you, Ala. I'm just sharing my screen. I hope my screen is visible and I'm also audible.
Yes, sir, it is.
Yeah. So thank you. Yeah, thank you, Solakoto, once again for this wonderful webinar. And welcome to all the attendees. Warm welcome from Growatt. Myself, Shantanu Shirsat. I'm taking care for all the pre-sales activities for Growatt in the Indian market. And for the next 10 minutes, I will be giving you a very much comprehensive outlook about Growatt as a company. What are the different products that we are offering, and towards then some of the uh, projects that has been done with Growatt inverters. So the first and the first, most important thing is that we want to build the world's biggest and the largest sustainable ecosystem for the humankind. And in order to achieve that, we are following that particular path. And we are very much hopeful that in the coming years, we would be able to achieve our goal. So, talking about Growatt, Growatt was founded in the year 2011 with an USD capital of $20 million. And basically, Growatt is a new energy enterprise which is completely dedicated for the research and development, as well as manufacturing of on-grid inverters, energy storage solutions. Lately, we have also entered into the EV charger segment as well as smart energy management solutions. Talking about the different milestones that we have achieved in the last 13 to 14 years. So, founded in the year 2011, this was the same year in which we came with our subsidiaries in Australia as well as in Hong Kong. In 2012, we launched our first single phase 5 kilowatt inverter. And going ahead in 2017, we entered into the top 10 inverter suppliers for the string inverters as per the Frost and Sullivan report. In 2019, we launched our battery ready inverters in single phase ranging from 2.5 kilowatt up to 6 kilowatt. And in 2020, we launched our Grow Home application, which is basically for the home automation, for which we were also the finalist for the Smarter E Awards. In 2021, we came up with a new manufacturing facility based out in Huzhou. Also, this is the same year in which we also became the number one supplier for the inverters in the residential segment as per Frost and Sullivan report. In 2022, we launched a new portable power system, and also we won the Red Dot award for the most innovative product design for our Infinity 1500 portable power station. Talking about the numerous growth that we have achieved in the last 4 to 5 years. So we are very happy to say that in the year 2022, we have reached the overall revenue of $1 billion, considering the sales for our on-grid storage solution as well as the smart energy management system. And if we are talking about the annual growth rate from 2019 to 2022 in terms of inverter revenue, then we are increasing by 63% every year. And surprisingly, in for the storage segment, for the last 2 years, the total compound growth rate was more than 242%. So definitely, if we look at this particular scenario, then storage is the new future in the renewable sector. Right now, we are having more than 1.9 million units on our cloud portal. And right now, we are having a manufacturing capacity of more than 3.1 million units annually. We are having our presence in more than 180 countries worldwide with an employee strength of more than 5.5 or 5,500 employees globally, out of which more than 1,000 engineers are dedicated only for the R&D purpose. Every year, we are spending more than 4.5 to 5% of our total revenue only for the R&D purposes. Talking about the market share by shipment, so yes, we are having ranking in top five manufacturers for the supply of on-grid inverters or the string inverters. Uh, uh, and if you're talking about the residential segment, then Growatt is ranking number one for the last 3 years with a market share of more than 19.9%. And if you are considering the user side storage inverter supplier, then for the last 2 years, we are also ranking number one in this particular segment. In 2022, as per the UPD Research Lab, we have received more than 21 top brand PV sales for our inverters as well as the storage segments for majorly all the continents in the world, for Europe, Africa, America, as well as for Asia Pacific. Uh, When we are talking about any manufacturing company, and that too in electronics, then definitely R&D plays a very vital role. And in order to achieve that, every year we are spending more than 5% of our total revenue only for the R&D purpose. So in the year 2022, we have invested around $48 million for the R&D expenses, and cumulatively for the last 2 years, our investment is more than $100 million. So if we are considering the growth rate CAGR in investment, then it comes to around 70%, 73% of the investment is done for R&D. We are having more than 167 patents to our name, out of which 120 are Chinese patents, more than 40 we are having international patents, and more than 10 software copyrights. Growatt's 20 kilowatt inverter is the only inverter tested by the Photon Lab in the year 2014 to achieve the maximum efficiency of 99%, 99.06% to be precise. Over the years, our inverters have also received the best commercial inverter award for TUV Rhineland for our Max 80 as well as Max 125 inverter. As I have already mentioned, in the year 2021, we have come up with a new manufacturing facility in Huzhou, where we are having a total capacity of inverter production of more than 3 million inverters. At the same time, we are also having our battery manufacturing plant where more than 600,000 units can be manufactured every year. This is a completely automated production line where we are following the Growatt's 5-step quality system. Talking about the global presence, right now we are having a presence in more than 44 countries worldwide. And if you're talking about India, India is the only country worldwide where we are having two service centers. One is based out in Hyderabad, and the second one is based out in Ahmedabad. And cumulatively, we are carrying the stocks of more than 20 megawatt in terms of spare inverters as well as spare parts. And in order to support our customers, we are having a team of more than 25 engineers for the after sales support. Now, coming on to the second section about the Growatt inverters that we are offering for the global as well as for the Indian market. So basically, Growatt inverters are extensively used in the application of residential rooftop, commercial and industrial applications, as well as for the utilities segment. So if you are talking about the residential products, then we are having the products in the range of single phase and three phase. In this particular area, we are also launching our new inverters in micro inverters for the residential segment in single phase or in the rating of 2 kilowatt. And apart from that, in single phase, we are having a range starting from 1 kilowatt onwards and goes to a maximum of 6 kilowatt. Whereas in three phase, it starts from 3 kilowatt onwards up to 15 kilowatt. The same goes for our C&I as well as the utility products. For commercial and industrial applications, the range starts from 20 kilowatt onwards and goes to a maximum of 125 kilowatt. Whereas if you are talking about the utility, we are having two different inverter ratings, mainly 250 kilowatt and 253 kilowatt. The major difference in these two inverters is the number of MPPTs. 250 kilowatt comes with 12 number of MPPTs, whereas 253 kilowatt comes with 15 number of MPPTs. Apart from on-grid solutions, we are also into energy storage segment, and we can provide range of capacities ranging from 2.5 kilowatt and can go to a maximum of 1 megawatt with a battery support of 2 MWH batteries. For microgrid, again, we are having a different hybrid inverters ranging from 2 kilowatt onwards and goes to a maximum of 300 kilowatt. So these are some of the inverters that we are offering for the global, and in the near future, we are also planning to launch it for the Indian market. So the battery ready inverters starts from 750 watt and goes to a maximum of 30 kilowatt. In that, we are also again bifurcating into single phase and three phase. Specifically, we are having an hybrid inverter in single phase as well as in three phase. And to support this, we are having We are also the manufacturing batteries to support these particular inverters in low voltage as well as in high voltage, and we can support it to a maximum of 52 kWh of batteries for the battery ready as well as the hybrid inverters. So this is just a SLD for the battery ready inverters, in which you can see initially the same inverter can be used as a normal on-grid inverter, but in near future, if the end customer wants to go for the storage, then just with an addition of some additional components, the same system can be used as a battery storage system. So right now we are already providing these solutions for the European, American as well as for the Australian market, and we are very much positive to launch this product in early next year. These are some of the C&I energy storage systems that we are having. That is the WIT series that will be also showcased during the REI, which ranges from 50 kilowatt onwards up to 100 kilowatt. And to support that, we are also having our own commercial battery. 210 kilowatt is the new product that we are coming up in 2024, which will be ranging from 200 kilowatt and can go to a maximum of 1 megawatt. For microgrid, we are having off-grid inverters in single phase, again from 3 kilowatt onwards, and can go to a maximum of 10 kilowatt. These are the portable power stations for which we have also won the Red Dot award in 2022. And majorly, this particular section of power stations are used for outdoor activities like hiking or as a home backup with a UPS system, as well as if you want to go for any professional where you need uninterrupted power supply, then definitely you can go with this portable power stations. Uh, we have also entered into the EV chargers, and we are having the AC EV chargers in single phase and three phase, and fast DC chargers in 20 kilowatt and 40 kilowatt. We are into smart energy management system, yes, and it is a very much ideal solution in order to provide a clean energy for households and businesses. And Growatt's basically smart energy solution is built upon the big data that we have collected with our experience from the last 12 to 13 years, and depending on that, it gives a very good predictions of the energy generation and the consumptions that can be achieved. These are some of the smart monitoring solutions that we are having, and as a Growatt, we are providing a completely free online portal for 25 years. Now these are some of coming on to the last segment, some of the global reference with the Growatt inverter. So this was just a case study in which a customer has installed a Growatt 5 kilowatt inverter in the year 2010, and after 10 years to go for Growatt inverters with new for the extension of his power supply, and the inverter installed in the year 2010 is still working without any issues. These are some of the ESS projects in South Australia, in Italy, again a EV charger plus hybrid inverter system, a completely off-grid system for South Africa, in Philippines. We have already different Royal Thai Air Force bases in Thailand, and some of the C&I segment C&I projects with Growatt inverters all over the world. So this is a 90 megawatt solar farm in Thailand using 20 kilowatt inverters for utility. Again, a 100 megawatt plant with 40 kilowatt inverter. Again, 127 megawatt plant with a string inverter. So these are some of the references where Growatt inverters have been used. So thank you once again, Solar Quarter, for this wonderful opportunity. Right to you, Ala. Thank you.
Thank you so much, Mr. G, sir. Here I would like to make a small announcement. Attendees can post their questions in the Q&A box, and our speakers will answer those questions at the end of the panel discussion. India's solar industry is on the cusp of monumental change, and this webinar is our gateway to staying at the forefront of innovation. In this webinar, we bring together experts, thought leaders, and innovators to explore the next gen solar landscape. Our expert speakers will delve into solutions and discuss recent advancements in solar technologies. So don't miss this opportunity to dive into the future of solar energy in India. So without further ado, allow me to introduce the elite panel for today. Mr. Gautam Samanta, Head PV Technology, Juniper Green Energy. Mr. Shantanu Srisat, Technical Head India, Growatt New Energy. Mr. Amresh Mahajan, VP New Technology O2 Power. Mr. Praveen Narkhede, Head Design and Engineering, Mahindra Sustain. Mr. Chintan Shah, Head Design and Engineering, Clean Max. And Mr. Srinivas Popuri, Group Head Quality, Green Co Group. Mr. Gautam Samanta, Head PV Technology from Juniper Green Energy, will be the moderator for the session today. Over to you, Mr. Samanta.
Okay, thank you. Thank you, Solar Quarter, for giving us the opportunity for the webinar today. And today's very important topic of the next generation's solar. We had witnessed a technological change. If you look into the 1954 onwards, where the Bell's Lab was the first solar cell, the research lab was founded, and there are several materials which are existing today in terms of the technology. And we started with the silicon, but silicon is one of the rawest technology. There are other technologies like amorphous thin film, gallium arsenide based materials, cadmium telluride, and then CIGS, and then quantum dot cells, and a lot of others technologies which was prevailing. But in the silicon itself, we had witnessed that smaller substrate to the larger substrate. And if you look into the below, before 2010 or maybe 2005, the polysilicon which is coming, the upspeak of semiconductor technology, and then the substrate size was also very small, 100 millimeter dia, and later on 125. And at a later stage we are giving a definitions of M0, M1, M2, and all, right? So today, the existing wafers are M10 and M12 or G12, 192 by 192, and by another one 210 by 210. But earlier, the mono wafers was pseudo square, or somebody is called hop square. But today, because of the fill factor, form factors, the dimensions, like almost a perfect square. So what I want to mean that there is a huge change in the technology in the larger, not only a larger substrate but thinner wafer. But we'd like to hear from our panel speakers, esteemed speakers. First of all, I will ask Amresh. uh, I know we have a 4 5 years back, from trolley to now. Uh, uh, Though it is p-type, but we are switching over to n-type, and there are several advantages. So what is your opinion that how the things will be changing in the another 4 to 5 years time? Right? Can you please share your process? Yeah, you have to unmute. Huh?
Mr. Mahajan, we're unable to hear you. I believe there's some error with your mic. Could you try
Unmute.
resetting it? Still not audible, sir.
So you can reconnect once more, huh? Right?
Yes, if you can reset the mic settings or just connect again on the backstage. still not audible, sir. Believe there's been some error with the mic. I request if you could reset the mic settings.
Uh, Maxity, or maybe you can rejoin, and if you want, then I
Yes,
can.
or you could rejoin and then it would
In the meantime, I think I can ask Praveen.
sure.
Is it okay, Amresh? So I'll wait a couple of minutes. Let's see. Okay, Praveen. In the meantime, can I ask you? Now there is a technological change. So from the developers' perspectives, we had witnessed the larger formats of the modules in a sense, like 550 watt or closer to 550 watt, which are in dimensions wise, 2.57 or 58 square meters, and there are other formats which are coming in a larger area, but that doesn't matter. But the most important part, what is the efficiency with the present systems and with your both either solar module as well as in the inverter systems, either in the fixed tilt or maybe single axis trackers. So there are huge changes. So how did you see that the changes has happened, and what will be in the future, as you have seen that monofacial to bifacial shift as well. Then glass, lower degradations, a lot of factors has come in. If you can share some of your thought process.
Yeah, so thank you for inviting me. And as we all see, the solar industry is very quick, and the development in the technology is very fast. So from poly to mono, and from mono to again now we are entering into the N type top core, and suddenly we will rush into the JT and all. So currently we are in the transition phase of monocrystalline PERC technology to the TopCon technology. So in TopCon technology or mono, there are certain advantages, as Gautam ji mentioned about the efficiency changes. So efficiency is definitely changed by at least 0.8% higher, and yielding to lesser area for the plant. At the same time, there are certain other parameters change like temperature coefficient. So temperature coefficient both for the voltage as well as the power is changed and improved a lot, and at least giving the yield difference of around 0.7 to 1% as a extra generation from these kind of modules. So also these technologies are offering better first year degradation, so LID loss are lesser. So we can expect at least 1% first year degradation including LID, and later on it will degrade at the rate of 0.4% year on year. So that is also improved compared to the zero point 0.5 or 0.55% of earlier PERC technology. So and also this is also improving to the repowering strategies, where we are actually repowering the plants to make sure that plant generations are not breaching the lower CF limits of the power purchase agreement over time. So it is more stable now. We can say 10% in 25 years or maybe 30 years reduction in the power, which is pretty good. Earlier it was very high to 15%, 18% range. Later on, there are the LETID risk, which was the main risk in the PERC technology. Now it is mitigated by the boron-free kind of doping, and that's a big relief, and that may be the surprise to any developer later on. Uh, Also, as we talk about the efficiency of the models is improved, and straight away there is a saving in the land area required for that. When we talk about the areas like Rajasthan, where there is a scope for bifacial model, there is a good albedo, as well as there is a better radiation level. So in that region, bifaciality is playing important factor for the bifacial model. So TopCon module have bifaciality improved at least 10 to 12% higher. That is also again adding up to the gain, and all these technological advantages are actually helping to get the same energy in the same reduced land area and maybe with the reduced investment. So at least on the BOS and other land related stuff. So that's how it is impacting positively to the industry.
Praveen, absolutely, you have pointed out the several things. So, what I want to say that today's from the developers' perspectives, first of all, we look into the equation. Amresh, are you there? Is it audible? I think there is a some issue without your. Is it okay, Amresh? Ayla, can you ask your team to help her, help him? Right?
Yes, sure, sir. I will look into it.
Gautam sir, can you hear me?
Oh yes, absolutely. Yes, 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 yes. So I think
All right, so
Praveen,
I've removed my speakers.
okay, that's great. Praveen, I will come back to your point. I mean, the points were so. What I was asking about that there is a huge technological change in terms of not only from the PTIP type, but also from the different format of the wafer size. Right, and also the thickness. And moving forward, these are called carb wafer. There are carbless wafers are also coming. So, if you can share of your, thought process, how we are moving, from park to topcon or HJT, and maybe way forward, peroxide with the tandem kind of a concept, which are slightly on a another 5 to 10 years on down to the line.
Sure, sir.
Yeah.
So, first of all, my apologies for the technical glitch which is happening, but unfortunately, I am at, and for my attire also, which is not appropriate for this forum. But unfortunately, I'm stuck at an airport, so you have to pardon me for all the inappropriate things, background noise, my attire, and everything.
No, no, no,
Now,
it's all right. Yeah.
coming back to the changes which has happened in last 10 years and which are going to happen in next couple of years. So trust me, I am not as experienced as Mr. Gautam. He is there in solar business right from Bharat Chhodo Andolan. He's there from 1942. So no, no, on
No,
the
no,
lighter
no,
side.
no, no, it's not right.
But being his disciple and being in this industry for last at least 16 years. So, the journey which we have seen is from, 180 watt modules or 175 watt modules to 540 watt monopole modules, which we are using currently. So, it was a 60 cell poly module, then it came to, 72 cell poly, then it became 72 cell mono, then mono perk, and now bifacial. And the journey is not going to stop here. We're going to see lot many challenges and lot many new innovations in times to come. Gautam sir mentioned a couple of those, HJT, Topcon. So I'll start with what we are doing now in terms of wafer thickness. You also touched upon. So earlier, they used to be 210 or 220 micron wafers, and when it came to 190 micron wafers, so there was all around there was a panic that what is going to happen. Will there be micro cracks in the field? Then from 180 to 170 and then 160. But now what I'm seeing, and currently, yesterday I was there to a manufacturer seeing the production. So the specification of wafer is 140 plus minus 10%. So technically we can have a wafer of 126 micron. I think couple of years back it was totally unheard of because people would say it will have micro cracks. But my understanding is that 126 micron wafer is being complemented by glass to glass. So if you see the micro cracks in a glass to back sheet, they would happen even in 180 microns. But when you use glass to glass, it is even 126 micron wafers. And we had one incident of container toppling couple of weeks back. Nothing happened. Trust me, I checked around 200, 300 modules. Nothing happened. The ones which got broken, okay, those were damaged. But other than that, there was absolutely no micro crack. So actually using glass to glass is first technological advancement, which is a boon for solar industry, which has practically eliminated all the micro cracks. This is one part. Now, earlier, when we talked about coming from 3.2 mm glass to 2 mm glass, people used to say, no, no, no. The tempering is very difficult in 2 glass, because lower you go on the thickness, tempering is difficult. So it is possible only in 3.2 But now in last 3 years we have seen, even with semi-tempered glass of 2 and 2 on the back side, actually it is a big advantage. So maybe 3.2 was more strengthened, but what we have seen in last 3.2 was more robust. But in last 3 years we have seen even 2 plus 2 reasonably strong glass, and it can actually eliminate the problem of micro cracks. This is one part. The second thing is now moving from P type to N type and HJT and TopCon. So N type is always a welcome, because it will eliminate the LID of first year. So technically, what it means is, if we are buying, if LID is say for example 2 to 2.5% in the first year, and N type doesn't have the LID, because in N type we have phosphorus in the ingot type and boron in the cell technology, rather than in P type where we had boron in the cell technology. It used to react with oxygen and create this LID. So practically, if I am buying 100 megawatt of P type, even if by 98 megawatts of N type, so I am logically on the same side, because then I'll be eliminating 2% of the LID. So this is another technological advancement which we are going to see in next couple of years. The third point is of course TopCon HAT. My view is it will be a 50-50 or maybe 60-40 in support of TopCon in next couple of years, because in HJT, although the long-term benefits are more, but the investment is also high. So people who have already created their lines with the current technology, it will be easier for them to move to TopCon rather than to HJT, because there you have to create the new infrastructure altogether. But to answer Gautamji's question, next at least 2 to 3 years, or maybe 3 to 4 years, so it will be a combination of three things. Either it will be TopCon with N type and G12 or G12 plus. When I say G12, it is 210, but I have seen people now trying to make 219 and 210, which is G12 plus. So in next 3 years, even this M10, which is 580 or 570, it will be eliminated. So the default product will be either N type with TopCon and G12 plus, or N type with HJT with G12 plus. So that is my forecast for next 2 to 3 years. But we also have to be cognizant of the fact lot of people in India have invested in technologies like polysilicon ingot wafer. So I am not sure what kind of technologies they are opting for, but in case they are still opting for maybe N10 or something like that, I can see this getting obsolete very soon. So my suggestion would be anyone who is opting for a new technology for investment in India, it has to be TopCon HJT complemented by N type as well as at least G12. So that is my forecast for the next couple of years. Thank you, Gautam sir.
Okay, thank you, Amresh. I think you have rightly pointed out. In terms of the thickness, I can tell you in maybe 30 years back, when I used to process the wafers, but those wafers are in the semiconductor grade wafers, and then as I told you, this is an obslic material is a 500 micron, 0.5 millimeter is the thickness, and today's thickness is a less than one third of 140 micron. What you are talking, right? But one of the biggest advantages that going to the lower in terms of the thickness, which enhance the solar cell efficiency. If you look fundamentally, what happens, the photon means, as I told you, after the Einstein's discovery of the photoelectricity, the electron and the hole, when it hit on the front surface, I mean, then how quickly for the P type, the top is negative and the rear side is a positive. How quickly the charge separations are there, and before it recombines. So that means it reaches much faster, right? So therefore there is a cumulative increase in terms of the efficiency with the lower thickness, number one. Number two, with the technological change, right? the current density, both the current density as well as the voltage, both are increasing from the park to the top corn, or maybe HGT, or maybe a couple of other technology are there, which is somebody is called the MWT, metal wrap through, or EWT, emitter wrap through, or uh, the other one is called IBC. IBC is integrated back contact solar cells. So N-type material has got some inherent advantage. What Praveen has also told, right? First of all, there is no such, LID losses, which are in the first years because of the boron oxygen, these things, one thing. And then what happens on that though, when you buy the module, even in the top one, the manufacturers are given first year maybe 1%, the kind of a degradation, though on a safety side, I know they want to play, because of the warranty on the, in terms of the degradations on the performance on the 25 years or so, right? But there are several other advantages, means from the PID perspectives, the potentially induced degradations are less. And number three, the temperature coefficient, which already Praveen has already pointed out, that when we switched over from the P type to N type, even in case of a poly, or the mono, with the poly or the multicrystallines, solar cells, earlier it was zero point 0.4 per degree Celsius per cell. And uh, in case of a P type with the mono park, it is 0.35. And going forward with the N-type material, particularly in the top one, zero point 0.3 to 0.29, and with HGT 0.27 to 0.26. So there is, as the India is very highly, the temperature sensitive, because the temperatures, cell operating temperature is going above 70 degrees Celsius in some of the areas, so therefore you get an additional advantage that on the top corner N-type materials, that the generations which Praveen has already told, So, Amres, the next way forwards, we have already pointed out that, the changing over, because this year itself, out of 450 gigawatt plus capacity in globally, including mostly with the 95% is China, that, switching over from park to top corn, more than 100 gigawatt, I mean, so from the capex perspectives and the cost of ownership, definitely AGT is more expensive. Number one. Number two is that, from the operating cost in the bill of materials, particularly on the silver and others, because silver is something like $950 a kilo, right? Okay, but in case of a cell conversion, that it takes about, somewhere is a 12 cent, per cell or something like that, the cost of ownership also plays a big role. And in that case, AGT may not be cost effective, not only in terms of the capex, but also in the conversion cost. Can you show some, on the cost ownership or something like in the cost process, that what you have witnessed in your experience now?
Sure, sir. So, sir, when we talk about the cost, there are two, perspectives to it.
Hmm.
One is looking from the developer's window. So,
Right.
since we are developers, so if you see the cost perspective from our window, no, we are not adverse to any technology. If technology is available, say for example, N-type Topcon, to me today, I'll be the first person to buy it.
Sure.
But the problem is there is a delta of around 1.5 to 2 cent between the premium product as well as which we are buying today. Now,
Sure.
within this 2 cent of delta, if you see the gain which I am having, number one, the lower LID losses, which means more generation. The second is basically the thermal coefficient factor, which means again I'll have higher generation in the field, especially in the areas like Rajasthan. The third thing is uh, 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 basically, so when I am saying the land is basically reduced, because if I am having higher efficiency models, so the cost of land is reduced. And third is the balance of system cost to reduce. But the problem is currently the module prices, if we take plus minus, they're hovering at around 15 cents for bifacial monopack module, and there's a delta of 2 cents between bifacial and if I have to go for say top con and type. Now this 2 cent in 15 cents means around 12 to 13% or maybe
True, true,
14%,
true, 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 true.
right? So if I'm spending 14% more on the modules, I'll expect a saving of 14% in the either generation
Generation,
or
yes,
lifespan or
yes.
land or
Mm-hmm.
balance of system.
Right.
Unfortunately, what is happening is if I do the entire calculation,
Hmm.
the total benefit if I am getting after spending 2 extra bucks is close to 8 to 10%. Where because of very lower tariffs, we
Mm-hmm.
cannot shift to the ultimate technology today
Right.
because the premium in the the by default product this is bifacial monoperk 550 watt 182 and the top notch product is so high that it cannot be compensated by the gains which I am supposed to get. So that is the reason typically Indian market is slightly slow in capturing or absorbing the newest technologies by couple of years.
True, true,
Same
true.
happened with monoperk bifacial. Same happened with 72 cell when it graduated from 60 to 72 cell. This is the unfortunate part. Although we know all the benefits, it's a better product. It gives better generation. But at the end of the day, we all have to come to the business requirements. And if the ROI with this better product is lesser than with the second better product, then we have to opt for second product. Now, this is from the developer side. Now, you very rightly said the cost of ownership from the manufacturer side. Again, if you see the time duration for next 2 to 3 years, definitely because of lower capex, the most popular product is going to be the Topcon. But if you see the benefits of HJT over a period of time, the potential of efficiency increase, which is much more in HJT than that of Topcon. So if you see after 5+ years, then actually it is the HJT which is going to rule. But the capex cost is so high that even the very new investors who have funds to cater to them, they are slightly apprehensive about going straight away to the HJT. They are either making it 50-50 Topcon and HJT or they're making it Topcon. So again, it's a catch 22 situation because of the higher capex. Indian market is a very very price sensitive markets, and we have to be cognizant of the fact that we also have to cater to very low tariffs at the end of the day. So, to answer to your question, we love the new technology. We love them. We love this technology to be adopted in India as soon as possible. But there are other reasons which prohibit us from doing so. So I think it answers your question, sir.
Yeah, yeah, absolutely, absolutely. From the developer's perspective, definitely there are certain advantage in terms of the technology, but yes, cost is a factor because the incremental cost, what you told, like the 14% on the capex, I mean, in the module itself, compared to the monoper, but the return are not that. Yes, there is a temperature coefficient difference, but even then that the LID, PID factors in. If you take about all these things, in the LCOE, which is called the denominator on the generation side, right? Okay, it's not that enough to compensate the whole investment what it is, But on the manufacturing side, yes, there is a capex involved, particularly. Uh, if we talk about the two different technologies, so monopark, something like $35 million is a per gigawatt level of the capex, but in case of a Topcon, there is a delta, yes, close to the $40 million, right, per gigawatt. But in case of a HJT, 70 to $80 million per gigawatt, in the double the capex. So there is a two factors in the financial side. First of all, the depreciation, and then the second one is that the interest on the capex, and also the other things which has already the bill of material, particularly on the silver paste side. I mean, there is a the change on that. So therefore, in terms of park or the top corn, though there is a little delta, but AGT will be far, far off in terms of the cost of ownership, at least 10 to 15 cents difference as on today, right? Okay, absolutely. Okay, so Praveen, I think you have rightly pointed out. There is a generations, particularly on the not Maharashtra, it's Rajasthan. Where the trackers are, much preferable, and particularly with the bifacial technology and with the glass, things. So we have seen that even with the single axis trackers and like 5 to 6%, we had witnessed the kind of a generations, advantage. And then if we have a single axis trackers, 15 to 20%, depending on the locations. And in terms of compared to the monofacial, we had seen that monofacial there is a back sheet, and in case of any kind of a micro crack or certain things, because back sheet is a kind of material where there is a moisture engraving, you cannot stop it. So there is a kind like a snail trail and other kind of a uh, degradations we had witnessed this phenomena. But which is in the glass, though, which Amresh has mentioned that it is not a completely tempered glass visit. Something like semi-tempered and all, but they are mechanically very stable compared to the 3.2 millimeter glass, 2 millimeter glass on the front and 2 millimeter glass on the rear side. It's give a mechanical strength and the sandwich. When you prepare the kind of laminations in the modules. So now the question is, as we are going to the thinner and thinner wafers, something like or cell, something like from 160 to 140 things. So in terms of the when we design a systems, either in the fixed tilt or in maybe single axis tracker or maybe seasonal tilt, how do you see that with the climatic change, in both the conditions, like static load is not a difficult, but particularly on the dynamic load side, where the wind speed is something like 80 to 100 kilometer, maybe sometimes more. So in that case, what we should do, in terms of your installations, in case of a string or the table, how do you take care of both single axis as well as in a fixed configurations? If you can share your thought process.
Yeah, sure. So actually, as you rightly pointed out, the glass to glass model is definitely having good stability or disturbances or mechanical impact of the wind or maybe any other challenges related to maintenance, maybe washing and cleaning and all those things. At the same time, you talked about backsheet, but backsheet is something that has to be properly tested, and therefore the glass to glass models are preferred over the backsheet now. The only thing is that the dead weight of the module will be little bit higher, and that need to be considered in the dead load of the model mounting structure design. So when we consider the extreme wind conditions during the storms or maybe during the monsoon season, there the plant structure has to be designed in terms of the wind tunnel analysis. So that is the analysis in the structural design where we have to consider with the inner, outer, and edge kind of a structure where the wind loading is actually the different wind loading at different part of the plants is considered, and that way the outer rows are made robust to make sure that that will sustain in the highest impact of the wind at that site. Plus, since when we worked about around Gujarat or somewhere where there is a coast is nearby, and when there is a cyclonic effect or as per standards or I standard 875 and all wind loading standards, so when the site is within 200 kilometers of the seashore or prominent seashore, then we should consider accordingly the cyclonic effect on the structure in design. So that's how I would say trackers are a little bit better perform in terms of higher wind, because there is a possibility of stowing them when there is a high wind. But fixed tilt structure once designed may not have that kind of flexibility to rotate or change it to different tilt, and they will experience highest wind speed and can collapse. So yeah, wind tunnel analysis and the coefficient of wind tunnel making sense, and I think industry is already shifted to that.
True. Thank you. I think, Praveen, it is absolutely rightly pointed out. But in terms of, sometimes when we design our structures, right? So what will be the, kind of the tonnage that we should look into the, something like, we should not go down below, 20 or so. What is your experience on that? I'll come back to the point, like what are the team you have pointed out.
So tonnage is a very dynamic thing. It depends on the wind zone where you are working and the tilt of the structures.
Yes. No, 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 no. I'll call you later.
Yeah. So
I, I
so sorry.
yeah,
Go ahead.
yeah. In terms of tonnage, what is the ballpark number? Is it 22 somewhere? Depending on the the location of the project as well. Definitely,
Yeah, it
what is the
depends on the
foundations
location of the project.
and foundations and all.
Rajasthan and maybe if you consider the marshy side, when there is a highest the tonnage can go in the foundation itself.
True, true,
So
true.
yeah,
Kacheria is also will be much more in
yeah,
Gujarat,
yeah,
right?
that there is also corrosion margin need to be considered in the structure width as well, thickness as well
And
as
also galvanizing and other things that we have to
galvanizing
be,
and the
yeah,
coating and all.
coating and all that. Absolutely. So I think you have rightly pointed out, in case of single axis trackers, during the high wind conditions, it can come in the horizontal position, so that have a minimum load. But otherwise, what happens, basically, when there is a thrust which is coming from the bottom, say, well, 100 kilometers per hour is a kind of the wind. What happens, as there are 4 points on the module, but in a string level, or the on a table, there is a huge thrust coming. So it's almost like it acts as a cantilever, in a sense, like it creates a kind of a resonance. I mean, therefore there is a huge a kind of a vibration, and therefore particularly for monofacial modules with the back seats. So there is a lot of witness the micro crack, but at least from the glass point of view, I mean, this is slightly in the safer side. Therefore, what I want to mean that the micro crack generations during this kind of the climatic conditions, the wind speed is more than 100 kilometers, but they perform much better. So Amresh, are you there?
Can you hear me, sir?
Yes, 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 yes. So, in terms of the technology, that a lot of new innovations are coming, and we have seen that India is always a little lagging about a year, but at the same time, we do a lot of DOEs, design of experiments, whether it is a
Can you hear me,
module.
sir? I am there.
Yes, yes, you're there, right? Can you hear me? Yes, hello.
Yes, sir. I can hear you.
Yes, yes. Okay. So sometimes, we bring our product, we audit the factory, we do the kind of inspections 24/7. We do a pre-dispatch inspections. We do a kind of a lab test, as far as the product which are manufacturing the fab. We have a 3 times EL. We have a different level of inspection, either visual or maybe EL, and then high pot test, flash test, blah blah blah. But post dispatch, during it transportations, loading, unloading, loading, in the during installation. So as a developer's perspectives, what are the things that we should take care? Maybe some sampling of the module with the portable EL machines in the installation site. What is your suggestion? Some do's and don'ts we should follow, right, as a developer or maybe EPC player.
Uh, Sure, sir. So I think, sir, if you have asked me this question, a
Hmm.
couple of years back, I
Hmm.
would have said the first preference in order to, verification of your product at site would be to do the micro crack checking, because that is the thing which was taking away the power from the modules for many years. But I think with glass to glass, personally, I have seen this problem has subsided a lot, and it's more of thing of the past, unless the cells are totally crack from the manufacturer's ends itself. So it's not a logistic problem now. So what I suggest is, if you have done all the diligence in terms of process checks, in terms of material check, and in terms of pre-shipment inspections, the only thing which you need to validate is, when the module reach your side, is that you have got the power which was being warranted by the supplier. So either you can have there are many mobile labs available now in India. So my personal suggestion is, if you can get few of the modules checked by a mobile lab, or if that is not feasible, then you can check, or you can send few of the modules randomly selected to a very reputed lab, and at least cross verify the power which has been given to you by the manufacturer. you know we talk about a 5 watt bin, but there's actually a very you know uh, 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 close binning equation coming to that. Just imagine, if you have a 551 watt module, or rather 550.1 watt module, and someone has jerked the power by just 2 watts, and you
Mhm.
end up having a 549. So actually, by lowering the power of 1.2 or 1.3 watt, the manufacturing is giving 5 watts. It's all dollars. So the tendency is to you know get the bins one notch up during the manufacturing process. So the my recommendation is to get few of the modules checked at a reputed site, either sending them to UL or TUV, or get the mobile lab and get the power validated. Because if your power is low, then actually you're going to have a lower generation and a lower PR for rest of the life. So at the very first instance, when you encounter a lower power, please raise the warranty issues with the supplier itself. I think that's the most significant part which a developer should be aware of when he receives modules at his stores.
Correct. Amresh, absolutely, you are correct. There are two things, that the developers are doing. First of all, there is a in-house O&M team, and they have a couple of diagnostics tools, whether it's a portable EL machines or the infrared imagers or the IV testers, right? So what they do actually, they randomly, when it is unpacked and before installation, they check, this kind of the module, maybe 5%, 10%, depending on the kind of the AQL standards or maybe internal quality, the team, and they perform this kind of a test. There is one more important things that we have already mentioned, like even in the 540 or 550 watt modules, there are three current binning, I low, I medium, and I high. What it mean is something like 12.7 ampere. I'm talking about the M10. 12.7 ampere is the current, and the voltage will somewhere is around 42 volt. Right? Okay. So when you make the table, something like 28 numbers. I'll come back to the Praveen as well. Let me finish with you. So these three category of the module, even they are maybe 550, but I low or IH or IM medium, in the carton in the box, in your palette, it is all 31 pieces. Normally it is 31 for M10, and pieces. This mentions with the serial numbers, and then there is a current. So there should not be any kind of this kind of a what I will say, a kind of a mixing in this particular process. But there is a chance. Praveen, I think we had witnessed that our table or maybe our string levels, what we do actually normally we make 28, but the in particular palette it is coming 31 pieces, and we mix up somewhere, when we open it, it is a high low, but operators are operating sometimes when it is there, they are doing two shifts operations. So there is a chance of mixing. Say for example, the particular box is IL, and there is a three module extra which is going to the the next table or somewhere, so how did you manage or count this kind of a mixing, which as we know that we are putting this module in a series, and there is a chance that the low current will be leading the whole string, and therefore there is chances of mixing, and the wattage losses in the as per your design, right? Okay, Praveen, if you can speak something on that.
Yeah. Yeah, so definitely the power binning as well as the current binning is important things to the projects, and the mismatch loss are badly affected. There is a very huge effect on the mismatch losses.
Yes, in the previous list, I think you have
Yeah,
mentioned like the
yeah.
DC, who is a power gain, right? Instead of a this thing losses, So those things are taken into the consideration. Absolutely right.
Right. So I think the mixing in the pallet itself has to be
Mhm.
controlled at the factory level. Most of the
True,
things, because
true,
there
true. It,
has to
it,
be
it, it is done, but in the
otherwise,
installation side, yes.
yeah, at site the labors are working, and maybe very difficult to take out one or two module from pallet and then install it somewhere else. very difficult. And I think generally we follow the strict binning current binning policy at site. We give the instruction to the site about installing I1 module at I1 place, and maybe I2 at I2 at M and H modules. So
Right.
that way we do. But yeah, the mixing at pallet level is very difficult to identify as well as, and
No, no,
to make.
not parent level. When it is when it's open in the,
Yeah, yeah.
in
When
a
you open
site
at
in the area.
site, when you open at site and you find four modules of different current binning, so it is very
Yeah,
difficult to.
so absolutely, Praveen. I think there are two things. First of all, when we sign an warranty, or maybe the module sales contract with the module manufacturers, there is a training schedules. I mean, there is a training schedules means not only that they will train how to, they install the whole thing, but there are a lot of do's and don'ts, in a sense, like, you should do like that, you should not do like that. I mean, do's. So those are the things. They visit the site, or maybe nowadays virtually. The first of all, the developer team, and also the small EPC player, and particularly the supervisors, right, they are trained. And also uh, uh, they have to cascade it down to the workers level, that you should do like that, you should do like, right. But somebody need to be supervised, in a much better way, right? Okay, thank you. Shantanu, are you there?
Yes, sir. I'm there. I'm there. Yeah.
Yes, nowadays, now whole the concept is that the DCAC ratio. Now, first of all, you can say both the product we have is string inverter as well as the central inverter.
No, we are only manufacturing string
String
inverters.
inverter, fine, fine. So
Yes, yes.
in a ground mounted project, utility project, you have witnessed for the last 12 years, so DCAC ratio was 1:1, but today it is 145 to 50% sometimes, above 40, you can say, right. So what kind of
Yes, correct.
stresses are developed into the inverter level, because inverter is the heart of the whole power systems. Somebody would say the power conditioning unit, but because this plays a big role from the DC on the AC side, right? Okay, whether
Correct.
so, how did you feel that this kind of, particularly when you are doing the overloading, and then there is a clipping, particularly from 11 to 11 o'clock to maybe 3 o'clock, because of the overloading. So how did you see that these components are live, their stress, including the LGBT and all, IGBT, sorry,
IGBT, yes.
sorry.
So yes, nowadays when we are going for any utility discussions, project discussions, definitely most of the customers are preferring to go with 40% or 50% of overloading, and basically taking that ratio into consideration. uh, as a designer and as a product developer, what we are taking into consideration is that yes, whenever you are going for overloading of any instrument, not only inverter, it definitely is going to have a stress on its component, because due to overloading, the major issue that arises is the rise of the temperature. And as it is an electronic component, they are very much directly temperature rise is related to the performance as well as the longevity of that particular component. But as slowly and steadily as the development and the research as are being done at very minimal level, so what the things that are being considered is that even though if you are overloading the inverter more than 25-30% or up to 50%, or maybe sometimes they need to go higher than 50% also, so we need to take care that a proper cooling mechanism is being provided to the inverter, not only for the external heat sink but also for the internal components. And in that particular aspect, IGBT, which you can say it is a heart of any inverter, because the switching losses or the deterioration or whatever the losses that can occur from a DC to AC conversion, that is being taken care by IGBT. But due to advancement in technology, the newer generations of IGBTs that are available in the market, are coming up with very minimal switching losses. So because of that only we are able to achieve achieve an efficiency of around 99% or a little bit higher than that. But yes, earlier I would have definitely said that continuously stressing the inverter up to 50% and the clipping losses that are occurring, it may have hampered the overall generation as well as the longevity of the inverter. But in current scenario, where all these factors are being taken into consideration, and a good and proper cooling mechanism is being provided, so that even though if the clipping is happening in the high generations and the inverter is working to its full potential, still the inverter with its design life of around 25 years, it can functional without any issues. So yes, these advancements are coming at the inverter end, due to which nowadays easily the end customer can achieve or go for uh, overloading of 40 to 50%.
Great, thank you. I'll come back to you regarding, there are several questions on the inverter side, particularly the remote area, how to operate, how to maintain, how to reduce the turnaround time, the quickly that you can have your service, and what kind of spares that one should have, and then particularly about the cooling mechanism, what you told, absolutely, whether the cooling fan itself is is sufficient, or there is a sufficient in the IGBT itself, the copper plate and the cooling mechanisms, what it is sufficient or not, but there are even in the string inverters, uh, I think it is a there are failures, but even what is the recommended numbers of string inverters should be in the site, so that it can take care of quickly, they can replace it. We'll come back, to you. Okay, Amresh, are you there? So in the technology itself, Amresh, Amresh, I think I'll take the next questions to, I think Amresh is not available. Praveen, so we are switching over not only on the technology in the module as well as in the systems, right? So way forward, we had witnessed like 600-volt systems, then 1,000-volt systems, now 1,500-volt systems. So next possible way is at 2,000-volt system. So what kind of the changes that you are likely to be in a system design that one should have, and getting an advantage maybe on the BOS systems, less number of structure, less number of the cable, less number of your foundations and the other costs, right? Okay, in both fixed tilt and the single axis trackers. Praveen, I think.
Yeah, yeah. So I think if it is 2000 volt, actually I have not encountered with such a real product, or maybe which can me I can work out. But broadly, I can talk about like when there is a 2 kV system on the DC side,
Yes,
then
yes, yes, yes,
then
yes.
there will be the module has to have that kind
Yeah,
of.
I'll talk about the module BOM as well. Amresh, I'll ask Amresh
Yeah,
on that.
sure. Okay.
Yeah, yeah.
So generally, when there is a high voltage, then
Yes.
definitely there is the cable first need to be relooked for their insulation voltage with the ground to the phase voltage, or maybe in case of the transients, or maybe the inverter switching pulses, that time it should not experience the voltage more than 3.3 kV or 1.9 phase to ground volt. So that's the first thing we have to look at. And later on, the combiner boxes and all other devices are rated for 1500 volt. The fuse and everything, the disconnect device, everything has to be rated to that level. It's not only reduction in the cable lengths, but it is more on the reliability of the component, the tested component that can ensure the reliable operation of the plant over a long time. So that's the more concern to me.
Okay, in an ideal condition, say for example, that you are a 180 kilowatt kind of a string inverter, right? Okay,
Mhm.
and in 540-watt modules, right? Okay, about 545, something like 43 volt is that the module wattage, So what do you do actually? You normally in 1:1 ratio, you connect something like 12 numbers of string in that particular inverter, right? Okay.
Mm-hmm.
Now this is called 15 volt systems. If there is an enhancement of another 30% on that, so what I mean that, 1:1 ratio, something like there will be, instead of 12, another 30% increase. So you can have, at least 16 such strings which will be connected to the system, number one, in a but in case of a 40% overloading, or 45% overloading in the same 2000 volt systems, so you have to have somewhere, maybe 14 to 15 these things, the string length. So therefore, what I mean that in terms of the structures, cable, and the other cost,
Yeah.
there is a reduce, but the foundation, you have to see the self load, the static load. Foundation mean the structure load as well as plus module load, both the things, so module is something like, with the bifacial, something like 33 to 34 kilo, right? So in an ideal conditions, like something like 1 ton is the self load, another 1 ton is that the module load, right? Okay, so it has to increase. So what I want to mean that from the foundation point of view, that and also for dynamic load conditions, but wind tunnel test, which has already mentioned. So a couple of things need to be taken care of, when it is accommodating, more number of modules in a string, right? Okay, and also it will be connected in the string as well. Okay.
Yeah, so DC capacity will be same, but the only
Same,
thing
yeah.
is that number of module in series, instead of 29, 28 module,
Yes,
it can go up to
exactly.
35 or maybe 40, 37 models in series.
37
And
model,
that will
38 model
reduce
string.
the number of string and related fuses and other thing, cables and all. So that is the saving. But structurally, if the 540 watt peak model is only keeping 540 watt peak, then there the efficiency is not changing, the structural cost is not going to change.
But down to the line, maybe another 3 years time, definitely Topcon nowadays, a couple of the developers are already importing here as far as the ALL, with the LLM, these things, but instead of 545 or 550 modules, so you'll be getting somewhere is a 575, 580 watt modules, so there is a increments in terms of per square meters, something like 10 to 12 watt, so today we are getting in the monopod somewhere something like 210 to 215 watt per square meter, right? Okay. So in case of Topcom, this will be something like 220 to 225 watt per square meters, right? So there is a enhancement, in terms of the watt, per square footprint in the same footprint, right?
Right.
Amresh, are you there? So in case of
Yes, sir, I'm there. I'm there,
yes,
sir. I'm there.
yes, 200 volt systems, I mean, which may be switching over maybe another 2 years time. So we have discussed a little bit about the systems, but can you throw some light on then how, from the module perspectives, that it can, the system design in the module systems, when you design it, whether it is a anodization, the thickness, the aluminum frame, the glass, then inside the EV or the POE, and also the other materials to be taken care of, such a increment in terms of another 500 volt systems, including cables and all, junction box, diodes, and everything, right?
Right, sir. So I think the first thing which we need to take care of is the cable thickness. So for 4 square mm to 6 square mm, when
Correct.
this G12 came, there was a talk of going from 4 to 6, but somehow people are still saying that even with G12 they can manage with 4 square mm cables. So
Hmm.
I'm not into that engineering, but I think that's a very significant cost impact. And whenever we move from maybe M10 to G12 to G12 plus, the thickness of cable is a very significant impact which needs to be seen. Another thing I think which needs to be keep in mind is uh, uh, the maximum fuse rating.
Hmm.
So basically, currently we are at the maximum modules are being designed at 30 ampere fuse rating.
Correct.
So I'm not sure with again 650 watt or possibly going to 700 or 750 watts. So what is going to the next fuse rating design? I've seen people designing systems in India, with respect to 1.25 delta, which I'm not sure is a very right thing to do. Generally, we should take care of. We should be doing it with 1.55 delta. So again, that's a thing which engineers have to keep in mind while designing the system. Whenever they do higher current rating with 1.25 delta system as current rating, there's going to be some challenges with respect to that. So, and rightly so, we have to somehow migrate to the string inverters. The reason being, whatever improvements that have taken place in module technology, but still the soldering of junction box remains a very very big concern. The automation of this soldering in junction box is a area where full automation has not been achieved. Now what is happening is, because this remains the only manual activity, I have seen, when you do the drone thermography, many modules, they are detected because the soldering is not proper. And especially in areas like Rajasthan, where the temperature is very high in the peak daytime, the connection between the solder and the cable gets off, and during the peak time the module doesn't function. So unless we again switch over to the string inverters, and string inverters can very pertinent string inverters can pinpoint to which module is not performing. When we are having central inverters, the SCADA is not so advanced that we can pinpoint to the modules. So that way string inverters are very very effective in the sense they can pinpoint which module is not working, immediately can cater to that. We have seen over the years that SCADA systems are, up to this inverter level, and unless you do either module to module, this ampere check, or string, which we call it string check, or you have a drone thermography in a 500 megawatt plant, invariably you'll find maybe 1000, 200, 3000 modules absolutely not working because the junction box soldering is not proper. So these are the areas I think we should take care of while moving to the next generations.
True, true, true. Absolutely. You have rightly pointed out the most weak link in the whole module system is the junction box diode and its assembly, right? Including the soldering process, right?
Right,
Coming
sir.
back to the point, like the higher ampere rating of the current, right, from the M10 format, which is 12.5 ampere to 12.6, 12.7 or so. But in case of G12 or M12, 17.5 ampere, 17.6, 17.7. This is the monofacial mode. But when we operate in the bifacial mode, there is a minimum, depending on the albedo, voltage is not changed, the current there is a gain, and when you are connected in parallel, that means current will be double, so therefore the fuse ratings and all sorts are very very critical, including the incremental benefit because of the albedo, I mean because of the bifacial gain, right? Absolutely good. Praveen, I think we had and you are also just rightly pointed out, right, the string inverters had got 14 different features, right from the MPPT, if there is a swelling losses, if there is a shadowing, if there is a microcap, there's a bar drop, blah blah. But I mean, all these features are inbuilt in such a way that you can very quickly check, what kind of malfunctioning either on your particularly on the module level, right, in a string, in a string level in the module, right? So there are several features. So Praveen, I think in a string level, string inverters that we had witnessed that these are the advantages, right? Okay, but from a high temperature perspectives, when we design our systems and then there is a voltage losses, including particularly uh, the temperatures we operate, maybe delta is 25 degrees Celsius, and definitely what are the things that we should take care of? I mean, something like only the PV and the other design parameters, right, on the voltage side,
So I think string inverter we will have lesser mismatch losses. That's
Mm.
by maybe theoretically we can say that. And practically also the way same, because one string per MPBT, which is having
Right, right,
the
right.
best case scenario where every string is allowed to experience different voltages due to the binning and maybe whatever differential soiling or differential shadowing and whatever the ways the difference in coming in voltages that can be accommodated by string inverters. The placement of string inverter is also playing a very big role, because when we install string inverters normally below modules, that is the
Yes,
ideal
yes,
case we see,
yeah.
where module is actually working at 80 plus degrees centigrade during the top summer.
Right, right.
And
Inside the cell temperature. Yes, yes, yes.
Yeah, so backside of the module there is a high possibility that it will have the air around module is heated. And the string inverter, I think earlier the string inverter design were without fans. I
Mm.
don't know what
Now,
now they are coming up with fans,
with
or
the fans,
maybe just
yeah.
convection.
Yes.
So the sync and all the alignment of that, the airflow, the ground clearance, all those things matters. So if that is trapped, then there might be chances of overheating in that, and that can malfunction. And maybe the failure rate of string inverter compared to center inverter is which is one of the thing which I think everybody is looking at because of these problems like installation or maybe all that. So that's a thing. But otherwise, yeah, the technically on the DC side, it is the best way to connect the strings and extract the maximum power from the modules.
True. Have a better control definitely on the string side. Yes. Thank you, Praveen. Santanu, as a quick fire questions, for you. I mean, the time is only 3 to 4 minutes. So, what is the kind of the product warranty that you are giving in the string inverter?
If you're talking about the utility segment,
Utility. Yes,
yeah.
yes.
So for that, from our side, we provide a standard warranty of 10 years. So
Okay, good.
that is
So, what is the
yeah.
uptime? What is the uptime?
Uptime that we are following for all our customers
Is it
is
is
around
it
99.5%.
99%? Is it
Yeah,
99%?
99.5. We are trying to achieve it,
Okay,
and in
good.
order to do that, we are giving some spare inverters at the site itself, along with some spare
Okay,
parts.
okay. So, what is the efficiency level that you are guaranteeing?
From inverter side, it is greater than 98.5% that we are
But you're
claiming.
not 98.9, you're not near to that one?
99
98.9?
is the maximum efficiency that
No,
we have achieved.
98.9, but 99 you have achieved, huh? That's fine.
Yes,
Okay.
yes.
Okay. What kind of consumables that you normally, prefer, like including fan, including, the SPD switches or the cooling mechanisms, something like auxiliary, the power losses and all. What are the things that,
Yes, so majorly with inverters, yes, fan definitely it needs to be maintained because it is a continuously moving item. So that we are keeping at site as a spare item. Along with that, DC connectors we are providing. So in case of any burning issues that are occurring on the DC side regarding the connectors, we are providing as those spare parts. Along with that, some spare PCBs for displays as well as for SPDs that are also being provided along with the inverter.
great. So, as you have rightly pointed out, there are two service center that you have. Where are the
Yes.
two service centers?
One is based out in Hyderabad for South India and eastern part, and for northern and western part, we are having the service center based out in Ahmedabad.
Okay, okay, good. I think the time is up at 4:30, 4:29. So, Ayla, anything in the questions, any specific questions that you have, or any? I didn't see in the chat box there are any questions.
Yes. So thank you so much, sir. Thank you so much to all our panelists for that impactful, insightful session. I believe there are no questions posted by the audience here. And other than that, if anyone would like to make any closing statements.
Yes, Santanu, if you want to have any statement that in one line.
Yes, so definitely this is a particular field in which we have seen a lot of development starting from 2010 onwards when I joined this particular solar industry. From 2010 to 2023, there are a lot of changes that has occurred not only in the PV module field but also in the inverter segment. So yes, I think with the iteration of and the research and development going on in this particular field, definitely in the near future, uh, more friendly and more easy and maintenance-free inverters we can expect in coming days or coming years.
Exactly. You have a huge opportunity, 250 gigawatt plus another 7, 8 years time in
Yes,
India. Good.
correct.
Praveen, anything that you want to make a
Yeah,
point?
I think yeah, we are waiting for all these technologies coming up, like maybe heterojunction and all TopCon to stabilize, and eagerly waiting for validated pan files and all those things where we can take better calls. We can have the risk mitigated approach. So that's the expectation from the manufacturers. That's
Okay, great, great. Amresh,
Uh,
switching over from
yeah. So,
from
sir,
manufacturing to the developer side, from the manufacturing developers, you are doing a lot of
yes, sir.
DOEs, a lot of practical things. Very
Yeah.
interesting. From the
So thank you, sir. It's always been a privilege to be on same platform with you, and of course, thanks to all the co-panelists. But I think next 3 to 5 years will be very very exciting for the solar industry, and especially for technological savvy persons like us. And please remember that we have talked about only next 3 to 5 years. Had this debate been about next 5 to 10 years, then of course we would have discussed perovskite, which possibly
yes.
will be a game changer in times to come. So hopefully will be in business and will enjoy all the technical innovations, and most importantly will like these innovations to happen in India. Thank you very much, everyone.
Okay, thank you, Amresh. I think you've rightly pointed out, today what we're doing, whether it is Spark, HJT, or the top core. So in the silicon side, this will be the bottom line of the crystalline materials. On the top of it, there will be a thin material which is called the top corn, which is coming as a peroxide material, which is thin, another thin film which are coated, and then what will happen? So the bottom will be 25% efficiency and the top one will be another 5%. There are two different configurations. One is the two terminal negative positive that you can take the terminal of what is the conventional, or maybe four terminal you can have. The efficiency will be 30% plus, and that will be very, very stable by 2028 or 30. People are working on that around the globe. And as you know, there are a couple of companies like the Cubic PV. They have more than 100 patents. Right? The Oxford. They have done a lot of research on the peroxide materials, and then it's very, very stable. And on the wafer side, there are things like what we are using the sliced wafer, but there will be a kind of a carfless wafers, which are also coming, for future as well. So there are a lot of technology innovations will be changed another 5 to 10 years time. Thank you, Solar Quarter, for giving us such a wonderful platform for discussions, all the technical points. Thank you.
Thank you so much, sir. There have been a couple of last minute questions that have been posted. If
Okay, okay.
you
What is
would
that?
like to cover them, I'll
Yes,
just
you can.
display them on the screen.
Do you agree that the pace of technology enhancement in the solar modules is not the very encouraging, considering the solar project have been the lifespan of at least 25 years? Okay. Unless you can take the question, but I think it's not.
Sure, sir.
Yeah, you can throw some light on that.
Yeah. So first thing, the lifespan itself has changed from 25 to 30 years
30 years,
in the
absolutely.
last couple of years. This is number one. But I think we have seen enough of innovations happening in solar. If you compare it with mobile technology, I would say more innovations have happened in solar if you compare it with the fastest growing technology, that's the mobile technology. So, as I started by saying that in 2008 and 9, we used to have only 60 cell 170-watt modules sitting on 144 cell 650-watt modules. I don't think we should be complaining at all to our scientists and the research persons. And this is just tip of the iceberg. In times to come, I think we'll see lot many innovations. And you know the important point is, if you change every day, then it is very difficult for the consumer to adopt to these innovations, because solar panels or solar projects are very high valued projects. So we have to give some space for at least one technology to sink in, and then you can come with another technology. If there is a change everywhere, then I think this whole model itself will going to collapse. So I think enough technological changes have taken place, and we have very exciting times in our hands.
Great. Thank you. Thank you. I think, yes, in the project side, definitely, I think, I don't know, every developers has got an engineering team, and then right from the foundations, I mean, what kind of, DC cable, what kind of the different structure design, what kind of different, the SCADA systems and weathering stations, plus, the on the AC side as well. I mean, people are doing a lot of innovations. How to uh, and innovation means there are two things. First of all, maintain the quality. The other thing is that how to reduce the LCOE. I mean, the cost as well. Right? Okay, that people are doing that. Thank you. Any other questions, Ella?
Uh, More than so other a statement I'll just display it on the stage if you would like to comment on it.
Significant advancements might leave us with a limited spare options during the operational phase. Therefore, we might need to invest in the module at the project's outset, incurring additional upfront cost and required extra storage. So, storage, I think, Amresh or Praveen, if you can answer these questions.
Yeah. So definitely when we the question, I think if I understood correctly, then today we are installing TopCon, and when at the 10th year the operation of the plant, we will require some spare module. So at
Yes,
that time that TopCon may not be available, then we may have to install other module, other technology governing technology at that time. So for that, yes, we have to make some initial planning for the module storage, so that our the structures are matching with that, or else we have to do the inverter level repowering maybe. So that's
abs-
one of the way we can.
absolutely. I think you have pointed out, during the discussion that repowering in some places that you are doing, in a sense, like, yes, there is a systems which has been installed maybe 2010 to 2012, which are 600-volt systems, and then accordingly today you want to do repowering, then you have to have, those in place, and then you do the reverse engineering as well. But definitely you have to take an approval, both from the uh, you know uh, uh, from the the power purchase agreement that you have signed with the with the authority and all, that you can do. Right. So some extra always we order, maybe 0.5% or so, the extra modules. Yes, we keep it in stores, as an extra, so that to match particular the whole as the dimensions as well. If it is too long, maybe 10 years is very difficult. Yeah. Right. Okay. Thank you. And any other questions, sir?
That's it for the questions part. Thank you so
Okay.
much.
So thank you so much, to you, as well as Solar Quarter team, as well as all panelists for sharing their valuable input for today's webinar. Thank you, Praveen, Amresh, and Shantanu, right, and Sakshi as well.
Thank you so much to
Thank
all the
you. Thanks a lot.
panelists.
Thank you, thank you.
Thank you. It's been
Okay,
quite an insightful and impactful session, and the comments from the audience are proof of that.
okay,
Thank you, audience, as well, and a very special thanks to Mr. Samantha for superbly managing the session.
thank
And
you,
a
thank you,
big
ma'am. Thank
shout out to our sponsor Growatt for their immense support to organize this event. We
you,
promise you to come back soon with more sessions.
thank you. Bye bye. See you soon in REI.
Yes, see you
Okay,
all. Yes. Thank
Thank
you.
you. The floor
next
is now
week.
open for
Next week.
questions.
Okay, great. Thank you. Bye bye.
Thank you all. Bye bye. The floor is now open for networking.